Okay, this is a problem dealing with one-dimensional motion with constant acceleration. The acceleration, it's in free fall, so the acceleration is the same throughout the entire problem. So this should be pretty easy, I hope. We'll start by making a table of our assumptions and so forth. Now, of course, like with any other video, if you haven't already solved this problem on your own, or at least seriously attempted it, you need to pause the video now and seriously attempt this problem, or you're not going to get anything out of the video. So, let's see what we know about this. For the motion of the stone, I guess, it's going to go up and down. We'll make up positive and down negative. That'll be our sign convention. And it reaches maximum height in 2.2 seconds. So we're going to start by just considering this first part of the motion here, where it rises up to maximum height. And for that, we don't know what the maximum height is. We also do not know the initial speed of the stone. At maximum height, we know the y velocity is 0. It's kind of a hidden assumption in all maximum height problems. We know that the acceleration is negative 9.8 meters per second squared, so it's in free fall. Right? The acceleration points down. Down is negative. So there we go. And the time is 2.2 seconds. So we have 3 of our 5 quantities. We can solve part A now, which is asking for the initial velocity. We use this equation. So 0 is equal to v0 plus negative 9.8 times 2.2, which gives us the initial speed of the ball, which is 22 meters per second. Now for part B, it's asking what's the average velocity of the stone during that 2.2 second interval. Right? It's not asking for the final velocity or the initial velocity, but the average velocity. There are 2 ways to get that. Maybe the easiest way is to use our average velocity equation, which is that the average velocity is equal to the distance, or the displacement divided by time. We can get the displacement using this equation, right? The equation that doesn't have the initial velocity in it. So that's 0. Notice how the negative signs cancel out, so we're left with a positive displacement, which is consistent with our sign conventions. And so from this, we get that the average velocity is 23.72 over 2.2 seconds, or 11 meters per second. An alternative, and you may remember this from when we first derived our 5 equations of motion, but we know that when the acceleration is constant, we have another equation that the average velocity is just the average of the initial and final. And since the final velocity, or since the initial velocity is 22 and the final velocity is 0, that also gives you 11 meters per second. That's a little obscure, though. I don't know if you would want to do it that way. Part C is asking for the average velocity of the stone during the 4.4 second interval between launch and return to ground level. Well, okay, so for the entire trip, if you start here and end here, then your y displacement is 0. And so the average velocity is 0 over 4.4, or 0. Okay, that's it.